Good morning, all of you. My name is Nirav Shah, that is Nirav Sir. So, on the behalf of the Jain classes, I am welcome all the audience and listener to this video series. Today, we are discussing the topic that is useful for the first year diploma and first year BE or BTech aspirants who are studying in the first year. So last time we are discussing about mechanics, that is introduction to mechanics. Today we are discussing about the properties of matter. So next thing in your mind first, that what is pressure, or some says that pressure. So what is pressure? So there are several types of pressure that first we are discussing here in this video series. So first one is called the atmospheric pressure. So it is the force per unit area exerted into a surface by the weight of air above that surface in the atmosphere of the earth. Second type of pressure is hydrostatic pressure. Is the pressure exerted by a fluid at equilibrium due to the force of gravity. Third one is called osmotic pressure. It is the pressure which needs to be applied to a solution to prevent the inward flow of water across a semi permeable membranes. Fourth, arterial blood pressure. It is the pressure exerted by circulating blood upon the walls of blood vessels and is one of the principal virtual signs. Fifth one is venous blood pressure. So it is the measure of pressure in the venous system, and the pulmonary vessels play an important role in intensive care medicines but requires an invasive central venous catheter. Next is 6, that is called intraocular pressure, that is IOP, that is fluid pressure inside the eyes. Next is 7, interactional pressure, that is ICP. So it is the pressure inside the skull and thus in the brain tissues and cerebral blood fluids, that is called CSF. Next is buoyancy. So it is an upward force exerted by a fluid that opposes the weight of an immersed object. Column of a fluid pressure increase with depth as a result of the weight of the overlaying fluids. So basically this video is only for these who belongs to engineering background only, not for anything else. So if you are belongs to anything else, then this is not for you, because you do not understand the language of engineering. Next is Archimedes principle. So any object wholly or partially immersed in a fluid is beyond of a force equal to the weight of the fluid displaced by the object. So buoyancy is equal to weight of displaced fluid. So appearance immersed weight equal to weight, that is the original weight, minus weight of the displaced fluids. So if we calculate the density of an object divided by density of a fluid, which is equal to weight divided by weight minus apparent immersed weight. So here we are considering the two examples that these things you are already learned in your 10th or 12th science. So just I am revising the things because these properties of matter, introduction to mechanics. So we are have the bridge course like things. In this bridge course like things, in each and every year we are using this type of things. For the 3 weeks we are revise the 10th or 12th, that is the all subject maths and science in our engineering sessions. Before start the actual syllabus of engineering, we already revise the students who are studying from the schools, that is 10th or 12th. So we can revise one more time in our colleges, and we are then start the teaching. So this is the part of it. So that so many things they are learning, we are consider that school teachers are very well trained and very well proper, and they teach properly. So that's why we are assuming these things only. So next is example number 1. If you drop wood into water, buoys will keep it afloat. So in this particular example, you consider that if you throw a stone is going to downwards. But if you throw a wood, then it will float. Why float? Because the buoyancy is there. The force is going to downwards, which is less than the force is upward. Second example is a helium balloon in a moving car. In increase the speed or driving a curve, the air moves in the opposite direction of the car's accelerations. Next is Pascal's principle. A change in pressure at any point in an enclosed fluid at rest is transmitted undimnished to all points in the fluid. So change in pressure, that is delta P, that is called hydrostatic pressure, is equal to rho g into del H. Well, delta P is hydraulic pressure, rho is density, g is acceleration due to the gravity. Next is the applications of the Pascal's principle. These Pascal's principles you are already learned in 10th science. The Pascal's principle, Archimedes principles, and so many principles, Bohr atomic models, all things you are learning in your 10th science textbook. So we are just follow the things. So here you are considering the applications first. Siphon. So you are know the siphons. It is a one type of instrument which is used to record the song. It is called siphons. Second one is called hydraulic jack or hydraulic pressure. Third one is braking systems. Fourth one is artesian walls, water towers and dams. These are also work on the Pascal's principles. So how to work on? If you know the answer, you should write down in the description box. Otherwise, I can tell you that how it is work. With the help of these buoys, Pascal's principles, so that is called the properties of matter, which you are already learned in your 11th and 12th science and some concept in 10th science. Next is surface tension. So it is a contractive tendency of the surface of a liquid that allows it to resist an external force. Surface tension, represented by the symbol R, is defined as the force along a line of unit length where the force is parallel to the surface but perpendicular to the line. So I have so many questions related to my 11, 12. This type of things that school or tuition class teachers you have already trained. Some basic questions that I am asking in this particular video. Run or walk in the rain? First question is run or walk in the rain. Second questions, catching a fly ball with the help of Newton's law, running a yellow light. This is the third question. Fourth one, getting the bat there in time. That is fourth question. Fifth question is turn on, turn or stop, friction plus Newton's law. Then sixth one, the secrets of the golf swings. 7 jumping beans, 8 jumping, 9 throwing the baby a slow one, 10 karate punch, 11 hammers, 12 soft balls and hard balls, 13 heavy bats, 14 jerking chairs, 15 click batters somersault, 16 the weight of time, 17 pressure regulators, 18 the super ball as a deadly weapon, 19 locking brakes, 20 wides like on a car, 21 frictions in drag racing, 22 sliding sticks across the fingers, 23 accelerating and braking in a turn, 24 starting a car, 25 left on the ice, 26 turning a car, bike and a train, 27 pool shots, 28 super ball tricks, 29 bike design, 13 hula hoops, 31 keeping a bike upright, 32 cowboy rope tricks, 33 spinning a buck, 34 fiddlesticks, 35 Eskimo rolls, 36 large diameter tires, 37 car in a icy skid, 38 tire balancing, 39 tearing toilet paper, 14 skipping rocks, 41 car differential, 42 racing car engine mount, 43 tight trophy with walk, 44 carnivals bottle swings, 45 falling cats, 46 skip turns, 47 yo-yo, 48 slapping the man in judo, 49 bullet spin and drift, 50 the learning towards a book, 51 falling chimneys. Then we are moving forward. 52 the Falcon Iceland battle and big breath. 53 Beer's law of river erosions. 54 a net twist on the twirling ice skeleton. Next is 55 squalling chalk. 56 a finger on the wine glass. 57 two-headed drum vibration. 58 bass pressure into the records. 59 whistling stand. 60 booming sand dance. 61 challenging figures. 62 pickling the banjos and fingering the hards. 63 string telephones. 64 bowling a violin. 65 plucking a rubber band. 66 the sound of a boiling water. 67 murmuring brooks. 68 walking in the snow. 69 silence after a snowfall. And 17 reaping cloth. So these are the main 70 exercise that you are already done by yourself at your home, which indicates the basic idea of engineering. This video is only for the first year engineering students who are clear his or her 10th and 12th and be the part of engineering colleges. So these are the main 17 ideas that actually demonstrate how the engineering things are useful in day-to-day life and why they are studying engineering. Why? they are studying engineering. And what is the advantages of engineering in day to day life? So after the engineering, which type of field they are considering? So that is getting from this type of exercise. Each and every unit have some meaning to put in your syllabus. So if you doing this type of exercise, then you can clearly understand that why the engineering syllabus is different from ordinary syllabus, and what is the main power of engineering. If we are doing mechanical engineering, but what you are doing in mechanical engineering, and yeah, you are just doing mechanical engineering and doing the job in companies, that is only things? No, that have particular reason why mechanical branch is developed, why electrical branch is developed, why computer branch is developed. Because in our early days, if you showing that there is nothing like called engineering, that is called ITI is also there, certified courses are there, but why we are doing the engineering? So this type of phenomena we are studying, we are using this type of phenomena to study proper topic. That why engineering is different than any another branches. So this video is only for the students who are the viewers or listeners who are first year in engineering. They have these basic fundas very clear. So if we start our engineering session or engineering course, before that we are revised 3 weeks, approximately 3 weeks revision is there, their school lives, okay, what they are studying and that how they are using that topic in day to day life. I am just discussing one small topic, and it's this small topic we are getting 70 question. So if you are showing the whole syllabus of 11th and 12th or 10th, there are so many questions which are there. So I am just here discussing one small topic, that is called properties of matter, and I have the 70 questions. What we are discussing here, three things we are discussing, and out of these three things I generated the 70 questions. So if you like my videos, then you can like my channel. Do not like my video, do not like. Or if you like, then you can subscribe the Jain classes. My name is Nirav Shah, that is Nirav sir. If you like the Jain classes, then you can subscribe my channel Jain classes on YouTube. Thank you for watching this video. If your audience is listenable this video, then you can follow this video, because this video is only for the engineering students, not anything else, because you have the some knowledge about the engineering that is required to solve this. So thank you for watching this video. My name is Nirav Shah, that is Nirav sir. On the behalf of Jain classes, we are closing our video right now. So if you have any difficulty, any query, you should write down in the subscription box. If you know all the answers of all the 17 questions, then you should also write down in the description box. If you do not know, then I can tell the answer of each and every question if you write down in the comment box. Otherwise nothing is available for it. So if you like my video, then one more time you can like, share and subscribe these Jain classes.